Hello, welcome back. This is me again, Al, on number 45 now. As I said, I did want to mention one thing more about constructor dangers and hazards. One particular one, at least, that you should be aware of, because it does come up quite often. And that's the following. This is included in one of my rules, although that's not the cause of this one. It turns out in C++, you can make a function, any function, foo. Suppose it takes 2 integer arguments. Let's actually make it do something. Max. So it returns the maximum of the 2 ints. If I1 is bigger than I2, then we want to return I1. Otherwise I2. Oops. Okay. Never in, please. So here's an example of a function that takes 2 arguments, and so I can call it. And we won't have it defined for this. Now let's call it underscore. Max int j max 4, 5. So it should give me j equals 5. Okay, and there it is, j equals 5. Now, it's possible, if you like, to give a default for one of these arguments. Suppose I said that I just, for some reason, I want to have a default argument. If I don't provide anything here, then I just want it to return the first number. Okay, so therefore -1 or int min or something. I think there's a define for that. Yeah. Okay. So as it is, it should still return 5. And here's j. It's 5. Okay. But now if I remove this argument here, it should still compile. Except this time, it's going to use the default. And I'll step into it to show you. So it's taking as I2 this value int min. And that value here, minus blah blah blah. That's definitely it. So that's going to be the smaller. The first one's always going to be the smaller and the larger of the two. Get rid of this. So I should get 4 in this case. And I do. Okay, now that's kind of a silly example, but I just want to point out that it's possible for you to define a function that takes a default argument. Now, you should never do that in a constructor. That's one of my rules. Okay? If you want to have a default argument, then make 2 functions. Don't have one function and a default. Have two separate functions. And the reason behind that, this won't be demonstrating that reason. This is demonstrating a different reason. This is a rather contrived example because I couldn't come up with a good example, but this isn't bad, I guess. I don't need to compile this to show you what's going on. We our rect object. I suppose we defined a way to compare rects, to say if one is equal to the other. So this left equals, the lefts are the same, the rights, tops, bottoms are the same. Okay, so I can compare rects. Now, so I can actually just ignore this. If I created a constructor like this for a rect, let's suppose that I thought, oh, this would be a convenient way to declare a square. It's going to be width and height. This is like width and height together. So, that simplifies my life. I don't have to write the same number down 4 times, right? Well, that may be true. But what this has done, okay, is it is provided now a way to convert an integer into a rectangle. And so along in your code, you might be wanting to compare, let's say, the width of 2 rectangles. And you might make the following mistake. You started out with if R2 equals R1. Oh no! I want the width, something like that, right? And then you realize, oh no, that doesn't make sense. Just want the width of that. And then the telephone rings or something, and then you come back and then you think, okay, it compiled, everything's fine. And what you haven't realized is that the compiler has gone around and tried to find a way to make this comparison. On the left-hand side here, we have a rectangle. On the right-hand side, we have an int, a width value. So it can compare a rect with an int. So what it's got to do is either convert a rectangle into an integer, which it can, or convert an integer into a rectangle, which it can. So it's going to take this width value, use this constructor, construct a rectangle, and then compare that rectangle with this rectangle. And so what this is an unintentional conversion from one type to another. Now there may be cases where you actually do want to convert an int to a complex object. And in those such cases, you should always write down the following keyword. Explicit. And that means that there won't be an automatic conversion from this into a rectangle. I have to say my rect and reinforce the fact that I really want this to be interpreted as a rectangle. In this case I wouldn't, and that would catch the bug for me. But generally speaking, it's not a good idea to have just a single value in here that is not related to the object itself. Now if you look at my string here, our string, we do have constructors that take single arguments. In this case, it's a string. So this conversion is actually an automatic one anyway. Here, this converts something of a similar type to our object. So we don't mind strings being converted into strings. In fact, that's often what we want. Just like we often want our strings to be converted back into C strings. Okay? So that was the point I wanted to add. That's not the only thing. But some of them I can't really tell you about just yet, because some of them do with this topic we haven't covered. This I just said. I think I mentioned before, no heap, that is malloc, those sorts of allocations in a constructor. And as a general rule, do as little work as possible in the constructor. Set a few variables and get out, and make the user of your object specify separately on separate lines exactly what they want. Don't put it all in the constructor. Don't give it like 100 different arguments to the construct itself. If there is such a case, then make a constructor that takes a great big struct as an argument. Alright, now I want to talk about the string class that we started with. Very little. We began with very little, and now there's quite a lot. Is that where I am? No. Let me open this. Wow, here we go. And I added a bunch of things, and I'd like to go through them one at a time. Some of them are very easy. Now, these are funny names, and you may not have seen them before. And what this is the function string strcomp. But the reason it's got all this funny _t stuff in it is because these versions are designed so that if you're building the project in a Unicode environment, it will use Unicode strings, whereas if it's in a multibyte environment, it will use multibyte strings. I don't know if you can see them both in here, but anyway, this tchar.h defines all these things. See? TsCS len is the same as multibyte string len. Some of the other ones. Some of them should turn up in gray. Yeah, okay. These would be the Unicode ones, probably. Yeah. MBCS means multibyte strings, and that happens to be, if you look at the command line for our compiling, this one, we have that defined. It's one of the definitions for our build is that we're using multibyte characters. Okay, and that was one of the first defaults that I changed, which was this here, which character set. If I change this to Unicode, all those functions would change to use Unicode character. So that's the business with all these funny names. Now, it's not too hard to read them off. CS means string, a C string. _t is, you don't have to even think about that part. They all start with _t, and then usually they end 3 letters of the usual string function that you're used to. So this is strcomp, string compare. Okay, so think of all this as stir, and we have stir conf. Again, stir conf. Here, again, this is like stir, so this is stir I conf. String, case insensitive, compare, same with that. And these bits, this underscore t thing is a macro that in multibyte mode does nothing. It's just it's an empty expression, whereas in Unicode it puts an L in front. It's hard to see it in here, but a wide character string of regular type like this is specified by putting the letter L here. That makes it wide characters. Same characters, but it's 2 bytes per character rather than 1. And all this T thing does is select one or the other depending on whether or not Unicode is defined. Now this might seem like an incredible pain, and it is sort of a pain, but I'm going to show you something that may help you with this. Maybe if I found it, well, I'll go down to the bottom and make copy some of this code. Now, this doesn't work in every case. But you can find the cases where it doesn't work pretty easily. Now, how do I undo this? See, I usually use a macro. First, I set up my macro with something that I can search for, which is going to be a key. And in this macro, I'm going to attempt to take these things away. So I'm recording a temporary macro. I'm trying to think of it. Now, is that a good search? No, a better search for me would be for a double quote character. Okay, let's try this. Search again, get back, delete, 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 search, search, space, delete, quote. Alright, now it's not going to work on the next one because I've got quotes in the string. But that's okay. It'll work on the next one. It should work on that one. That one's going to fail on this one. It'll work on the next one. On this one. Not too hard to find the ones that it fails on. It's just anything that had a quote in it. Okay. Now, in similar fashion, it's easy to make. Oh, now to take care of the single quotes, I just change my search thing to a single quote, run the same macro, and unhit or anymore. No, just that one. Okay. So you can work with your regular strings, and then when it comes time to put the underscore t's on, you can quickly make yourself a keyboard macro and go through like I just did. So I'll do it. I'm going to do it in reverse now. I'm hitting record. F3 for me means search again. Left arrow underscore T bracket F3 F3 right arrow close bracket and record. Now I'll fail in the next one. I knew about that. And Control Shift P plays the macro back. This is the one that doesn't like. No, this one. Okay, so it's not that bad. Something like that. Alright. Now, it's up to you if you want or don't want to use that macro. But a lot of code does use it, so at least you're familiar with it. It will save you time later on, unless you simply decide, I don't want to ever use Unicode strings, I always want to use regular strings, and that's fine as well. You can do that. However, you should be aware of at least one thing. You can still use the Unicode functions. There's no problem with that. You just have to name them specifically. And anything to do with a file in a Unicode, NT file system file, you must access that file using the Unicode interface for the file name. Otherwise, you'll be restricted to 260 character length file names. So, like for instance, here I've opened a file. Really, I shouldn't use the tchar version of this. I should use the wchar open version, whatever it is. I think it's wf. Probably this. And no t. Specify definitely that I want Unicode. And I gotta put this in front and get rid of that. Now I can use a file of any length I want. That's the one exception where you have to use wildcards for files unless you want to restrict yourself to like the length of the DOS file. Okay. Now back to the string class. Probably used all my time. I've used all my time. Let me just do one set of functions. So I did comparisons. There's two things to say about this. One, the thing I just told you about, what these wordo names are. You'll notice that they're referring to car stars, not to wide cars. And secondly, the code is not defined in a CPP file. It's defined directly in the header. So these ones are in line. Small functions like this, for small functions like this, it's okay to put it in the header. But if you've got a great big long function, you're better off putting it in a CPP file so that it's easier for someone to look through the header file mainly. And also, editing code in a header file is a nightmare. It means you have to recompile everything every time you make some change or notice a bug with your algorithm. You don't want to have to force everything else to recompile. So these are double equals, and that means, for instance, I can say, let's take this string, it's fine for me to not use this thing on this function, because this is a multibyte function as it is. So that's no problem. And this should come back true. And let's just watch it happen. Oops. So I'm going to step into this. That takes me to this thing here. And if I step into that, now it's doing a cast. Get the string values in order to pass into this comparison function, which is going to go to some runtime library thing. Step out, and the result should come back true. Would tell us, yeah, operator double equals return true, and so it's equal. Now, if I make this uppercase, try it again, it should fail. Step in again. Operator double equal return false. So it doesn't say it's equal. However, I happen to have in my list, as you saw, a case insensitive comparison, and this one, actually I'm really using this one in this case because I'm not comparing TsStrs and TsStrs, but anyway, I can say, is it equal in an insensitive kind of manner? In the brackets, yeah. Now it should come back equal again. Okay, it takes me here. I'll step out. Equally return true. So it's equal in that sense, case insensitively, and similarly for lowercase. Equal. As I said, if I had another string defined, something like that, I'm able to say I'm able to make that comparison, which in this case would fail, because this is not the case insensitive check. Failed. But as before, I can try that too. And this one should succeed. Okay. So those are the comparison operators. We could add, if we wanted, less than and greater than, or less than or equal to do, if we wanted to do not equals, like right now, I can't say this should not compile. Actually, this is a perfect example of exactly what I was just showing you about the automatic conversions. This innocent little comparison that any programmer wouldn't think twice about writing down. If you can say equals, you should be able to say not equal, will in fact produce the wrong answer. And it's due to an implicit conversion. You see, this is not a complete list here. And unfortunately, the way it's written down, forgetting about this part, there is a way to make this comparison, and that is to make each side a pointer to a string, and then just do a pointer comparison. And in fact, that's the only way. There's no ambiguity about what this says. As far as the compiler is concerned, this means pointer comparison, which is not what we want. So that is, just like in the other case, this is a case where we do want implicit conversions because it's very useful in other places, wherever it went. Where's our implicit? Here. We want this, but when it comes to comparisons, we have to be explicit about what's allowed to be compared and what's not. So, in fact, we need to have a not equals operator to tell the compiler explicitly what this statement means. So, basically, what I'm going to do, in fact, for all of these things, let me just do the comparisons with pointer. Equals we have. Not equals is easy enough. Okay. Now for the comparisons with other string objects, I can use these ones. So why don't I just say something like that. Similarly, oh, but I haven't shown you the bug, have I? So let me leave it out for the time being. Leave it as it was almost. Without having to find this not equals, let me just show you what happens. It will compile, and it knows exactly what it's doing. And in fact, we've explicitly told it to do it this way. First a cast, then another cast, and no function called. It's compared for pointers, and those pointers are not equal. Okay? Now, we have to be explicit. Just like in the case of the automatic conversion that we wanted sometimes for an object, we have to be explicit. Then in the cases where we don't want it to occur. And this is one case. Now this should take care of that one. Oh. There's a reason why it's building twice like that. Now it's taking us correctly to eventually a strcon, which is where we want to be. It did take a few steps, but trust me, in computer time, that's 0. Okay, now, in fact, we didn't need to do it this way. There's kind of a, I don't know, we call it a theorem. There are only two things you really need to define in order to get all possible comparisons for any two objects. If you have equals and less, let's say, it's not the only step, but any two of these operations, you can generate all the rest. I'll show you why. Suppose we have this. Suppose we have these two operations. Then to get all the rest, we define them like this. A not equal to B. I'll use the logic symbolism for if and only if. If, this means if and only if. Okay, so now we have not equals. Now what else do I want? I want A, let's say we have less, greater than or equal to B. That's true if and only if it's not the case that B is less than A, since we can do less than, right? B being less than A means A is greater than or equal to B. So now we have these two. And A less than or equal to B, which we still don't have, is true if A is less than B, which we have, or A equals B, which we have. Okay, and what are we missing? B bigger than A. B less than A. It's true if and only if. B is that? No, we have less than. What am I missing? Greater than or equal to, less than or equal to, well. I see A bigger than B is what we're missing. That's true if and only if B is less than A. Okay, so you can actually generate all of them from just these two. But I'm not going to do that, because that's all fine and nice and elegant in theory, but in programming practice, it's always better to be clearer than it is to be elegant or beautiful or anything like that. I've written them down this way. Everything here is in one-to-one correspondence with the comparison function, and all of these will use these in exactly the same manner. There we go. Okay, now that's clear. There's no ambiguity about this code. This is dumb, plain old code that anybody can read. There's no elegance about it. It's simply a one-to-one match with these, as long as I didn't make a typo. Again, on this side, all I'm doing is invoking these. And so, although it's more typing, and there's less code reuse, this is something a person can easily read. Now, what about equi? Equi is not an automatic, is not something the compiler automatically knows what to do with. It knows how to compare, it knows what to do with double equals and pointers, but it doesn't know what to do with this and pointers. So even though we haven't added anything to this, we're safe with that conversion. And so that's essentially, I guess, why people say that this is a bad idea. But I don't think that you're going to come up with many other instances where the automatic conversion is going to hit you. Really, we never want to see pointer comparison, right? Now, as far as I can tell, that's taken care of. There will be no more comparing of pointers with pointers for our pointers in this string. And that's what we want. And I can't think of anything else, any other case, where we wouldn't want the comparison. I mean the conversion. So I may be wrong, and somebody might prove me wrong. There's no automatic way to detect that I know of. All I know is that you have to be very explicit when it comes to comparisons when there's an automatic conversion to pointer, and make sure to eliminate any possibility of a pointer comparison. Alright. Okay, I've used too much time, and I'd like to do more of these functions. I'll upload this and I'll start making the next one. You can get to them when you get to them.